Thank you very much for the invitation. I mean, it's really a pleasure for me and Gemma to be here and to present. Thank you for all of you for being here. So I am Nans Addor, and so Gemma Coxon and myself have co-led the creation of some large data sets for catchment hydrology. And what we thought we would do today is to share with you our experience and tell you about how these different data sets came together, and also give you a bit of an overview of other data sets, other initiatives of the same kind. And it's really actually an occasion for us to also reflect on how much progress has been made really over the last few years, and to tell you about where the field is heading. So our motivation really over the last few years has really been to make hydrologically relevant data easier to use by people and also publicly available. And we've been using open methods and creating data sets that interestingly have brought together many people, much more than what we thought at the beginning when we released these data sets. And so we've been working with data from hundreds to thousands of catchments. And this means really that these data sets cover fairly large spatial domains, and that they involve a fairly high level of hydrological diversity. And you might say, okay, well, so you do large-scale hydrology then? Well, yes and no. I mean, we share a lot of interest with people who do large-scale hydrology, but our focus is really on river flow, whereas in large-scale hydrology, focus is on flow, but it's also on other fluxes, for instance, evaporation. And our focus is also really at the catchment scale, which means that we work with a domain that is often not really continuous, whereas in large-scale hydrology, often people work with continuous domains, which typically would be output, for instance, of large-scale models. So we talk about this field as a large sample hydrology, and it basically simply implies that we work with large samples of catchments, so many catchments. And it's, as you'll see today, a rapidly evolving field, and this has really only been possible because of all the people who've invested time in the creation of these data sets, and also because of all the users who have decided to use these data sets and make them popular, and have decided to share their findings. So the outline of the presentation today will be the following. I'll start by giving you a very short introduction to what large sample hydrology is, what does it come from, why is it relevant? And then Gemma will give you an introduction to CAMELS GB and present an example application. And then I'll be reviewing some of the key challenges that we are facing in large sample hydrology. And I'll be discussing ways to overcome them, one of these ways being the project called Caravan. So looking back a little bit and trying to understand where we come from. So in 1989, Falkenmark and Chapman published a UNESCO report on comparative hydrology. And comparative hydrology has a lot in common with large sample hydrology, because it's very much dedicated to the study of how processes are influenced by climate and by the nature of the Earth's surface and subsurface. And it's very much about understanding interactions between hydrology and the ecosystem, and trying to determine if, when we make a prediction somewhere, we can transfer it to another location. So this is very much what large sample hydrology is about. And there is an important actually milestone in the development of large sample hydrology, I think, and it is the release of a data set called MOPACS. And some of you might be familiar with MOPACS, you might have already used MOPACS. And MOPACS was released in 2006. And it includes data from hundreds of catchments in the US. And by data, I mean time series, so flow, temperature, rainfall, and also catchment attributes. And I think it's quite interesting to go back to this paper and to think about what makes the name MOPEX. And MOPEX really stands for Model Parameter Estimation Experiment. So there is a very strong modeling component in this name and in this data set. And actually, this data set has been used a lot during the pub decade for prediction on gauge basins. And clearly, the idea that using several data sets is important has been around for quite some time. But it had really accelerated the advance of large sample hydrology. And so here, it's just one example showing how people became really aware of how effective testing requires that models are tried on many catchments of widely different characteristics. So obviously it's true for models, but it's true more generally for conclusions that we might formulate in hydrology based on catchment data. It doesn't have to include models. The larger the sample, the smaller the risk of reporting results based on one specific, maybe, outlier. And really, large sample hydrology as a term, I think, was really made popular by this paper by Harshin Gupta and colleagues published in HAS in 2014. And in this paper, they really advocate for the fact that there is a need for a balance between depth and breadth. And by depth, they mean data that we find in, for instance, very well instrumented catchments, so very rich data sets, many variables are being measured, but we have very few of these well instrumented catchments. And between them, there is not a lot of very rich data. However, there are many, many catchments for which we have some data. And this data often is flow. And so we have thousands, obviously, of catchments for which we have flow that we can use to balance the deeper data that we get from very well-studied sites. And the main objective that they highlighted were to, well, improve understanding of hydrological processes, to formulate conclusions that have some statistical robustness, and also to help with classification, regionalization, and model transfer. And this might all seem pretty clear, make common sense. And I imagine that many of you are working actually with data from many catchments for exactly these reasons. So to some extent, I'm preaching the choir, but I think it's still very useful to go back a little bit. And one good reason to do it is to realize how much progress has been made. So in this 2014 paper is an interesting table. And so it's this table, and it shows which resources are available for large sample hydrology. And broadly speaking, we have two kinds of resources. You have runoff data, flow data that you can get, for instance, from GRDC, or you can get from the USGS, or from a dataset like MOPEX. And then you have more atmospheric datasets, like, for instance, EOP datasets that provide atmospheric data for the whole of Europe. What's interesting is that in 2014, there were very, very few datasets that combine flow, atmospheric forcing, and landscape attributes that were really publicly available, right? If you have a closer look and you look at the last column, some of the datasets, for instance, flow datasets for France, the data are available upon request. And you and I know that it means that sometimes you can get access to the data, but it's not 100% certain. So this is another component, of what large hydrology was in 2014. And obviously, there are also still very large spatial gaps. So a lot of flow data only available for places like the US, UK, Australia, and France. And it's obviously still a problem now, but we're working on ways to overcome this. So things, for me at least, changed quite a bit in 2015. So in 2015, I joined the National Center for Atmospheric Research, which is based in Boulder, Colorado. And I did this picture because it's probably the most beautiful location my office will ever be. And I've worked with Andy Newman on the left, Martin Clark, and Naoki Mizukami to create a dataset that would become the CAMELS dataset, which was really developed at NCAR. And I just want very briefly to mention that I work for Fathom currently, and Fathom is a flood modeling company, and we distribute a range of products. But CAMELS and Caravan are not products that Fathom is distributing, and I'm presenting them today because I contributed to the development. So when I joined NCAR, Andy Newman had just published a data set which include data from 671 catchments over the US. And this was more catchment that you would get in MOPEX with more recent data, longer time series, a better coverage, and a very wide range, basically, of hydroclimatic conditions. So here you're looking, for instance, at precipitation. You can see that because it's the US, the range covered goes from a few hundreds of millimeters per year to more than 3 meters. And this data set included daily time series of atmospheric forcing and stream flow observation for all these catchments. And you can do a lot with just these data sets. Especially if you're interested in rainfall runoff modeling, you can definitely calibrate many models and compare models using just this data set. But if you're more interested in understanding catchment behavior, you need to know a little bit more about all these catchments. And this is why a lot of my time at NCAR was dedicated to creating a complementary data set that would contain information characterizing the landscape of these different catchments, their climate, their hydrology, their land cover, their soil, and the geology. And when I was working on it, we decided that it should be part of the data section of a paper. And then when this data section reached 15 pages, we decided that it was a bit ridiculous, and we decided to publish it as a paper, a standard paper. And this and Andy Newman's dataset with a stream flow time series constitute what we decided to call CAMELS. And CAMELS stands for Catchment Attributes and Meteorology for Large Sample Studies. And we released it, made the data freely available. The code was made available on GitHub, and didn't know exactly what to expect. And a few years down the line, the CAMELS datasets have been cited in 250 studies, many of them actually using the datasets. The dataset has been used by academics, but also in the industry. And well, it has had much more success than we ever thought it would. And then the questions are like, well, what is it about these data sets? And I think it's a combination of these two components. I mean, the dynamical time series and the catchment attributes. It's ease of use. It's just there, very easy to use for almost anybody. It's open. The data set is peer reviewed. So if you want to know how it was made, you actually can know. And this really helped for the adoption of CAMELS. I also made a few stickers and drew this quite pathetic looking logo, but it helped. And in case you're wondering, in the background, the green waves are not waves; they're the flat irons in borders that I showed in the previous slide. Anyway, I think creating a sticker if you're creating a data set is something at least fun to do. So just very briefly to give you a sense of the different indices and attributes we derived. We derived climatic indices, hydrological signatures, soil characteristics, land cover characteristics, geological characteristics, and some network characteristics. And these complemented the time series that were already published. And what's interesting with CAMELS that CAMELS was published in the US, and then soon after, other CAMELS datasets were developed. And one of these datasets is CAMELS Great Britain, and I will let Gemma tell you more about it.
Thanks, Nans, and good afternoon, everyone. It's really a pleasure to be here. So yeah, given this is a British Hydrological Society webinar, I think we would be quite remiss if we didn't focus at least part of our presentation on some aspects of GB hydrology. So I had met Nans a few years before, and I'd seen the development of CAMELS US, and I'd been working for a very long time on hydrology in Great Britain, and collected all of these data sets and thought, well, why couldn't we do the same thing for GB? And really the idea and kind of the ethos behind CAMELS GB is very much the same as CAMELS US. And in that we wanted to produce a definitive, DOI'd, open access, large sample catchment hydrology dataset for Great Britain. We wanted to build on and add value to what has been produced already. And I think it's worth really noting that this was a big community effort. It's not just the University of Bristol that produced this data set. I needed a lot of help and support from members at UKCEH, at the British Geological Survey, and academics at the University of Exeter as well. So this was a real community undertaking, and I think that's important to stress. And it uses and develops a lot of incredible data produced, by our regulatory agencies, including the Environment Agency, SEPA, and Natural Resources Wales. What CAMELS GB contains is it contains data for 671 catchments that you can see in the map on your left there. You can see we cover a nice, got a good coverage of Great Britain, which is good. Spookily, it is exactly the same number of catchments as what's available in CAMELS US, which was not by design. For each of these catchments, there is a shapefile which gives you the catchment boundary. For each catchment, there is hydrometeorological daily time series from 1970 to 2015. So good long daily time series, really good for model evaluation, for looking at trends, for deriving kind of robust statistics of different flow indices, for example. And also for each catchment, we also have a whole host of catchment attributes. So ranging from climatic, hydrologic, geology, land cover, soils, and also to some more unique catchment attributes such as human influences and discharge uncertainties. The dataset is available on the Environmental Information Data Centre, and the paper is available in Earth System Science Data. Next slide, please, Nans. And what I wanted to do was tell you about a couple of the more unique aspects of CAMELS GB and how they're being used. So one of the really unique aspects of CAMELS GB is that we managed to quantify abstractions, effluent discharges, and reservoir capacity for catchments across England for the first time. So I was really fortunate in that the Environment Agency provided us with access to a whole host of data sets to quantify human impacts on the flow regime. So what you can see in the maps here is groundwater abstractions, surface water abstractions, discharges, and reservoir capacity, and recorded totals for each of those attributes. This is really unique. Trying to gain these types of data is really difficult for hydrologists. So yeah, this was something that's quite unique to CAMELS GB and has been used in a number of papers subsequently. Next slide, please, Nans. And one example, so I wanted to show you a little bit how CAMELS GB has been used. This is just one example of how it's been used. There are many others. But this is a really nice paper published by John Bloomfield in Hess last year. And essentially, John had produced, alongside other colleagues from the British Geological Survey, they produced a number of papers looking at climate, how climate and landscape attributes essentially were able to explain base flow index. So what the controls of base flow index were. And they had built this really nice conceptual model, essentially trying to explain how baseflow index was affected by these climate and landscape attributes. This is all very nice, but perhaps what they hadn't been able to do before was look at how water resource management practices affected baseflow. So what we wanted to do was kind of extend that conceptual diagram that you can see on the screen in front of you to also look at water management practices and think about how water storages, groundwater abstraction, etc., also impacted baseflow index. And the CAMELS GB dataset really enabled us to do that for the first time. And what we did is we assessed the impacts of water resource management practices on baseflow index using 2 statistical models for 429 catchments across England. Next slide, please, Nans. And what we found essentially was that water resource management practices do really affect baseflow. So what you're seeing here is a whole load of box plots, and they are outputs from the linear regression model. So they're comparing modeled minus observed baseflow index for 2 different sets of models. The set A model on the top, the green box plots show you what happens if we don't include any information about water resource management practices in our linear regression model. And what you can see is that we've got different water resource management practices across the top, so groundwater abstractions, surface water abstractions, and discharges. And we've got different box plots for different essentially quantities of abstractions or discharges. And you can see that as the groundwater abstractions increase, for example, we get larger discrepancies in our modelled minus observed. We tend to underestimate baseflow index, essentially, in those groundwater abstractions that are in catchments that are heavily, that have high amounts of groundwater abstractions. However, if we include this information in our linear regression model, so that's set B, the blue box plots at the bottom, we can see that we can get much better predictions of baseflow index. So you can see our box plots are generally better centered around that gray 0 line. Groundwater abstraction was found to be the most influential of these practices alongside discharges. But it's important to note that you know, a variety of schemes are used to manage water resources in the UK. And we really need much more information on these schemes to really dive into how and why groundwater abstractions are affecting baseflow index in this way. And we set out a couple of hypotheses in the paper, which, yeah, you're very welcome to read, or I'm happy to talk about at another time. Next slide, please, Nans. Zooming back out again, CAMELS really paved the way for new data sets and catalyzed the release of new data. So it's not just CAMELS GB and CAMELS US that is available. We also have a CAMELS Chile, a CAMELS Oz for Australia, and a CAMELS Brazil. There are also CAMELS data sets forthcoming for France, Switzerland, and Germany. So there's a real explosion of CAMELS data sets in quite a relatively short amount of time. These are complementary data sets in that they tend to include the same variables. So they mostly all have catchment shapefiles and boundaries. They include hydrometeorological time series, and they also include a whole host of catchment attributes. However, it is worth noting that whilst they are comparable to some extent, we've deliberately italicized fairly here because for the CAMELS data sets, we really concentrate on using the best available national data sets. And to do that, that means we might have different classifications of geology or land cover, which means that, say, you can't compare the geology classes used in CAMELS GB, for example, with the geological classes used in CAMELS Brazil. There are also CAMELS data sets that include different types of attributes. So again, the abstractions attributes are a good example of this from CAMELS GB. Abstractions are not available in other CAMELS data sets. Next slide, please, Nans. It's also worth noting it's not just CAMELS data sets that are available. and Nans and I are very aware that there is a whole host of incredible large sample data initiatives going on. And we've just highlighted two, there are many more. So we've got HYSETS here, which is a data set of 14,425 North American watersheds. And that includes daily flow time series for those watersheds. So really another incredible large sample catchment data set. And we also have the GSIM data set as well. And this includes flow indices for tens of thousands of catchments globally. So yeah, it's not just CAMELS. There are lots of other large sample data sets that are forthcoming. Next slide, please, Nans. So really, this is just as a summary to get to this point. We have made a huge, significant progress over the last few years. There has been this rapid release of new data, which is really exciting from a large sample hydrology point of view. And there's been a real large uptake of these data sets in academia and in industry for the reasons that Nans highlighted before, particularly related to their open access and their ease of use, I think, are the two key things. This is really enabling us to improve comparability of studies and from a modelling point of view, facilitate benchmarking, particularly of hydrological models. And something that, again, is super exciting, the emergence of machine learning models for hydrology as well. So these large sample hydrology data sets are really getting taken up by the hydrological modelling community and really enabling us to shed new light and new understanding on environmental change. That really links to new process understanding. And one example of this, next slide, thanks, Nans, is this a really interesting new paper. It was published this year in Nature Communications. This is just one example. But in this paper, the authors used CAMELS Brazil to look at how climate change was impacting streamflow trends across Brazil. And really, this is showing you the spatial distribution of accelerating, decelerating, wetting and drying streamflow trends across the whole of Brazil. Now, this type of study would have been very, very difficult without the CAMELS Brazil data set and without the large amount of flow time series and catchment attributes that were collated as part of that effort. Next slide, please, Nans. Whilst we're really excited about all of these incredible advances, there are still some remaining challenges. And I'm going to hand back to Nans to take you through what we're trying to do to accelerate that progress.
Thank you very much, Gemma. So a few years back, we sat down and tried to get a better sense of what we had achieved, but what the main challenges still were. And so we came up with a few important challenges that we decided to address. And one of them that currently there is not a global dataset with daily streamflow time series and catchment attributes. That's something that is missing really at the global scale. As Gemma mentioned, the comparability of different datasets remains quite limited because of the different national datasets that were used to produce, for instance, catchment attributes, especially when these datasets are qualitative datasets, for instance, different soil types or different land cover types. They're very, very difficult to combine. And finally, and this is something that I really want to stress, because it's not often very well recognized, creating and maintaining a dataset takes a lot of work. So I've been speaking with different people who've been behind the creation of the datasets, and we came to the conclusion that it takes between 1 and 2 years full time to produce one of the datasets. So it's much harder than what people might think sometimes. And obviously, this is a massive barrier when it comes to making more data publicly available, because not all institutions have these kind of resources to invest in the creation of a dataset. So what we proposed in this paper was to actually do things differently, and actually to move the production of these datasets to the cloud. And the idea what we developed was to have an online platform to produce datasets with minimum data. So it can be, for instance, only shapefiles and flow, and minimum effort. So making all the code necessary to produce a large number of data set available to people, and also providing the computing infrastructure for them to do it and direct access to the data. So it's a bit of a two-step process. We thought it would be very useful if users could upload catchment boundaries as shapefile, and if they had flow data, if they could also upload the flow data. And then the intersection between the shapefiles and the grids that contain attributes and atmospheric forcing could be done online. An advantage clearly is that you don't have anymore to download the entire source dataset, for instance, a global temperature dataset or a global soil dataset. You can only basically download the attributes that are computed for the catchment that you provided the shapefiles for. And we thought, well, I mean, something like this would be actually a fairly good way to address the different challenges that I just outlined. It would make creating these datasets easier. It will lower the bar, make more data being published. It would also mean that the different datasets would become more comparable because they based really on the very same datasets, and they were extracted using the same code. So the comparability would be improved. And we thought, well, it would be great if this could become a community initiative globally with different people contributing to data from different places. And just like for creating a large data set, it seems like, oh, well, it's something that should not be too difficult to do. It actually is fairly difficult, and it took many years to get something working. But we have something that we're very happy with and very proud to talk about. And it's a project called Caravan. And Caravan, as you might guess, brings together pre-existing datasets, including CAMELS datasets, hence the name. Caravan is a collaboration between the industry and academia. And there are many people at Google that are involved in Caravan, and notably Frederic Kratzert, who's really leading the effort and did a lot of the implementation of Caravan. Frederic is in the audience, so if you have questions, he'll help to answer them. And so we even have a much nicer looking logo than the one I produced for CAMELS, which was produced by Daniel Klotz. And Caravan is actually two things. It's an online platform for people to generate large sample datasets, but it's also in itself a global large sample dataset. We have produced a manuscript, which we've submitted, which is available online. And there is a link for the GitHub page where you can find the manuscript, access the data, and find a tutorial on how to contribute to Caravan. But let me walk you through these two components of Caravan. So the first component of Caravan is really the online platform. And this online platform relies on Google Earth Engine and on Jupyter Notebooks. And these Jupyter Notebooks are basically Python codes that are used to extract data from Google Earth Engine. The idea is that users upload shapefiles, and then on the cloud, we extract two things. We extract atmospheric forcing and some land surface variables, for instance, soil moisture and SWE, snow water equivalent, from the area land dataset. So Area 5 land was produced by ECMWF. It's a reanalysis, and it's distributed under a Copernicus license, so it can be used for any purposes, really, including commercial purposes. And then we use the global dataset Hydro Atlas to extract attributes for basically any catchment, which is the beauty of using a global dataset. And again, everything is processed entirely on Google Earth Engine, and there is no download of the source dataset that is needed. And the code is there for everyone to use the platform for any given basin. So that's the online platform component of it. But Caravan also has a dataset component. And so currently, the Caravan dataset includes about 7,000 catchments. Many of them are from the HiSETS dataset that covers North America, but they also come from the different CAMELS datasets and from the Llama dataset that covers the Danube basin. Currently, there is a cap at 2,000 square kilometers that we're in the process of removing. And you might say, well, this is great, but you still have very large gaps on this map. And it is true, but it's a map in a lat-long space. And how much does latitude and longitude tell us about hydrologic diversity? Couldn't we look at the same information in a different space? Well, we can, and we can look at this different catchment through the lens of climate zones. So here we've decided to use global environmental certification, so the GENS zones. And these zones are ranked from A to R, so from very cold to the left to very hot to the right. And the bottom part of the plot shows the fraction of the global landmass in each of these classes. And the top part of this plot shows the number of catchments currently in the Caravan dataset. And really, I mean, the coverage in terms of hydroclimatic regions of the Caravan dataset is, I would argue, already fairly good. But we want it to become even better, and our vision is really to create a growing community data set that will facilitate data sharing and increase collaborations. So we created a GitHub page, and in particular, we provide some instructions on how Caravan can be extended with new catchments. And there is a tutorial that basically walks you through the different steps that are needed using Google Earth Engine and notebooks to actually extract data for catchments for which you have submitted shapefiles. And I'm just really happy to report that there is already one extension to Caravan. Julian Koch used the Caravan framework to extract data for 308 catchments in Denmark. And what's here quite important to stress is that the license is selected by the user. And so Julian Koch selected this Creative Commons Attribution 4.0 international license, but other licenses can be selected, for instance, if you decide not to make your dataset available for commercial purposes. And just before we finish, I just wanted to give a shout out to the Robin project. Robin stands for Reference Observatory of Basins for International Hydrological Climate Change Detection. Sorry. It's an animal name, which is amazing. I fully approve. And the purpose of Robin is to assess impacts of climate change on flow. And for this, the team in charge of Robin are creating a network of partners to collect data, flow data from across the world, ideally from catchments with minimal human impacts. And the focus is very much on flow, and we're currently discussing whether Caravan could be used to derive attributes and atmospheric variables for these catchments. If you want to hear more about Robin, do contact Gemma Coxon, who is the PI on the project, and maybe, who knows, consider contributing to Robin. And with this, I'll conclude with these two QR codes that give you access to the CAMELS GB datasets and or to the Caravan GitHub page. I just want to say that Caravan and CAMELS GB are available now, so give them a try. You can definitely contribute to Caravan and would be much appreciated. You can add flow time series. You can add attributes, and actually Google Earth Engine has a very large catalog of data sets that could be used to extract more attributes than the attributes you get, for instance, from using Hydro Atlas. And yeah, and there is definitely a need to evaluate Caravan data and to compare this actual global data to regional, national data sets. And with this, I'll hand over to Gemma to tell you about CAMELS GB version 2.0.
Thanks, Nans. So yeah, we're starting to think about a version 2 of CAMELS GB, just in case number 1 wasn't quite enough. And with CAMELS GB version 2, we'd like to make a couple of updates. So firstly, CAMELS GB includes daily hydrometeorological time series. We'd really like to extend that with a set of sub-daily time series. And we'd also like to think about including smaller basins. So currently CAMELS GB includes a lot of kind of mid-size, or what I would term mid-size to larger basins in a GB context, so kind of above 500 kilometers squared. It doesn't contain many gauges on first order streams, so it'd be great to be able to extend that further. And just generally, if anyone has any ideas for new catchment attributes or further analyses they'd like to do using CAMELS GB, I'm always open to future collaborations and thinking about how we could improve CAMELS GB for the future. Nans and I would like to thank you all so much for taking the time out of your very busy schedules to listen to us today. Hopefully you've gained a sense of the really incredible progress that has been made in large sample hydrology and all these new data sets that you could potentially use as part of your studies. And with that, we end, and thank you very much.
Thank you.
That's brilliant. Thank you, Gemma and Nans, for that great, fantastic presentation. We've got a few questions coming in already. I thought I might just sneak my question in first, which was about, it was really curious, as you said, that you've got both 671 catchments in the UK and the US. So I wondered what criteria you used to arrive at those numbers, and just reflecting on your last comments there about CAMELS 2.0, whether that was mainly due to size criteria or whether there were other criteria as well. Yeah.
Do you want to go first, Nans, or shall I go?
You go ahead.
Yeah. So for CAMELS GB, what we wanted to do was include catchments with a good length of time series. And for that, I mean, we had a lot of conversations with UKCH, particularly Matt Fry and Jamie Hannaford. And what we agreed on in the end was that CAMELS GB included the service level agreement flow network. Good, I can see Lucy nodding. And essentially this is a network of gauges that have additional levels of quality control. I'm going to look at you, Lucy, to be honest, in terms of what this network is, but it has got additional QA and QC checks going on. So we started off with all the NRFA gauges, which is about 1,500-ish, and then we went down to 671 because that was the surface level agreement network.
Yeah, I have to say that 671 catchment is a pure coincidence. Not something we try to achieve. It's not a requirement either for CAMELS datasets. But for CAMELS US, the procedure was very similar. So we used a set of catchments that was selected by the USGS because the level of human impacts was very small, because the quality was high, and because the time series were long.
Perfect, thank you. Yeah, really, just very curious that you managed to get this exactly the same.
Really weird.
So I'll start going through. We've got lots of questions coming in now, which is great. So because we've got quite a few, I'll perhaps read them from the chat. But if you do want to ask your question in person, do raise your hand. Gareth Bradbury asks, how does Caravan and CAMELS, for that matter, deal with uncertainty propagation, i.e. errors in measurement and modelling that occur at each data or analysis step? Are uncertainty estimates available as layers, or are data products just caveats signposted to go to source files?
I can answer the question for CAMELS US. And Gemma has a few interesting and very useful uncertainty estimates for CAMELS GB that she'll discuss. So for CAMELS US, we don't deal with uncertainty very well at all. We do provide forcing from 3 different atmospheric datasets, which give you an idea of how uncertain the forcing is. But for the attributes, we don't really characterize uncertainty in those attributes. We think that an advantage of having the CAMELS datasets, the national datasets, and Caravan is that it will be a way to compare actually data that come from different datasets, like soil data coming from different datasets, and get a better sense of what the uncertainty is. But this is pretty ad hoc, so we haven't characterized uncertainty, for instance, in flow time series in CAMELS US.
Yeah, it's a great question, Gareth, and it's perhaps I hope Nans will agree here, perhaps something that we don't do so well. Generally, as I think a hydrological community, or as part of our data sets to quantify uncertainties and produce uncertainty estimates for the variables that we're providing. I think part of that is because of the availability of uncertainty estimates is really difficult to get a hold of. And there are, yeah, I think that's the main thing. It's really difficult to get hold of uncertainties. In CAMELS GB, we do have discharge uncertainty estimates. We do have uncertainty estimates on the flow time series, but we don't, for example, provide different meteorological time series. In CAMELS GB, we simply use CH gear for the rainfall, for the gridded rainfall, and chess PE for the potential evapotranspiration. Again, I think that's definitely something I should have had as a bullet point on my CAMELS GB version 2, is to include more uncertainty estimates. So thank you for prompting me on that.
Thank you for that. We'll come back to it. We've got a question here about kind of coming back to a little bit what we talked about in the first question about data quality. Claire Waller asked, are there standard data quality checks that have to be completed before data can be added, or stations, I guess, can be added to the data sets, or is it down to individual contributors? I guess thinking about Caravan here.
Yeah, that's a very good question. So far, as we've just said, we've relied very heavily on the USGS and on CEH to do a lot of the QAA analysis. For GSIM, that uses data from GRDC, a lot of QA has been done. And so it's something that can be used, but obviously there are only so many catchments that are covered by GSIM. I think it's very valid. And for Caravan, when people add their data, we will have to just document as well as we can what tests have been done to data, but we don't currently have a procedure that we ask people to go through before they can add data to Caravan. But yeah, very good suggestion.
Well, yeah, again, it's something in the Robin project that you mentioned, Nans, we're trying to work out how we capture different kind of data quality flags in a reasonably standard way. So perhaps something we can join up on there. So what other questions do we have? Lots of excitement for sub-daily data coming in CAMELS 2.0. Duncan Faulkner says, thank you for an illuminating talk. Did you run up against any difficulties with licensing data sets when compiling CAMELS GB, for example, for soils or land cover data?
Yeah, great question, Duncan. And I'd say, so Nans earlier quoted the amount of time that we think it takes to develop one of these large sample data sets at around 1.5 to 2 years. And I think at least 6 months of my time was spent on licensing, persuading people to hand me over data, and lots of time in meetings, pleading to enable me to put this together. The licenses was a big challenge, particularly for the abstractions data. Soils and land cover was absolutely fine because that was a UK CH product, and I believe that's already freely and openly accessible and available. So that was fine. The soils data, I believe we had to use a global soils data in the end for CAMELS GB because there wasn't an openly available national product. So essentially, most of the time what we did is try to find the best available national product. If there was no way that could be made openly available, we would then move to a global product. So yeah, the licensing took a long time, and there were some compromises made in terms of the quality of that data set, depending on what we could find that was open access. But I think Nans and I are very much of the same opinion that having something open access is the key goal here, that people can easily use, that can pick up from a website, yeah, that's the key goal. So some sacrifices had to be made.
Great, thank you. Great question here from Liz Lewis about, do you know if there's any work in progress around a global groundwater database in a similar vein?
Ooh.
I'm not aware of one, but I imagine Andreas Hartmann would be a good person to ask.
Yeah, good question, Liz.
Yeah, good question, Liz. I don't know.
Some other comments just coming back to the sub-daily data. Claire Waller also mentions that the EA's sub-daily data will be made openly available later this year through the DEFRA Hydrology Data Explorer. So there's for all those people being excited about sub-daily data, that's also coming via that route as well. We have and also thanks Frederick for joining us today, and he's also added a comment in response to, I think, the data quality and people adding catchments to CAMELS and quite how that works. So thank you for sharing that as well. Duncan has a question also on the sub-daily data, and he says, do you have a feel for how much shorter the temporal coverage might be for widespread hourly rainfall and flow data as compared to daily data?
Yeah, great question again, Duncan. So I'm not entirely set on which products we use, but let's say if we went down the path of using the CHGEO1 hourly product, that's from 1990 to 2015, I think, at the moment. So it would be a shorter time series, unfortunately. But perhaps what we would do is kind of make the flow data, whereas the daily data set is very kind of standardized between 1970 to 2015. I think for the sub-daily, what we might consider is making that time series a bit more variable between products. So if that flow time series was much longer, still releasing that, but then having a shorter rainfall time series to accompany it.
Great. So we've got some other comments around groundwater data. Frederick's recommended or knows of a PhD student in Hamburg working on something similar, and Jamie mentions there's the groundwater European Groundwater Initiative that BHS are running with collaborators across Europe. So potentially some interesting options there. Mark Futter has a good question about how and who is funding these initiatives.
Do you want to tackle that one, Nans?
In most cases, there is no dedicated funding.
No.
It's in case for Gemma and myself, at least, I mean, things we've done on the side because we need data for a project and ended up investing a lot of time as part of our PhDs and postdocs, and then release the data sets. I think there is really a challenge here. People really see, and it's more and more the case, the value of these data sets, but don't always realize the costs of creating these assets. And it's difficult to get funding to work on these projects. And this obviously means that in terms of continuity, things are not as good as it could be. On the bright side of things, I think like projects like Caravan, where things are more decentralized and become easier, will help to basically lower the cost and lower the bar to create these assets.
Yeah, just to add to that, I think Nans, correct me if I'm wrong here, all the CAMELS data sets have been produced by early career researchers, by postdocs. And it happened very organically. We had a really great group of early career researchers who were spread across different institutions globally. And essentially it was all produced using side projects and spare time on postdoc projects. So that's, yeah. I agree with Nans. I think the production of these data sets is possibly a little, it's hard to get funding to produce these types of data sets.
Yeah, really, yeah, great efforts from everybody involved. I think really valuable, especially thinking about Caravan and all the opportunities for people to produce and extract data and those tools that you've created. So yeah, thank you. It's really great. We are coming up to the end now. I'm just trying to see if we have one final question. I think I can't find it now, but I think Duncan was asking another question about kind of updating the data, and obviously you're thinking about CAMELS 2.0. Are there plans to kind of update things more regularly, or is it going to be a periodic thing when people have the time and resources to do so, given it's such a large effort?
Yeah, I mean, I think we would plan to update all the daily data sets as part of CAMELS GB version 2, but again, it's going to rely on resourcing to do that. You know, it will take at least a year's worth of postdoc time to develop version 2, and so yeah, unfortunately, regular updates just aren't possible without kind of a funding stream that enables that, and I don't know of any currently.
Yeah, there has been an update of CAMELS Chile, but for CAMELS US, we are not planning an update. I think a lot can be achieved through Caravan, but it's more an extension of what's already there.
Yeah, great stuff, and another global groundwater data paper project in the chat from Ross there. So thanks for that. So hopefully lots of resources there if you're interested in groundwater, or contacts if you want to do something together, I guess. So we're just over time now, so I would really like to thank both Gemma and Nans for their time and a really great presentation today, particularly one with such good projects with such good names and good logos, so I always appreciate that one. So yeah, thank you both so much.